All right, quadratic equations. We're going to start with the standard form. And we talked about this a little bit last week when we were factoring. We're going to start with factoring again today, but we're going to be solving by factoring. Standard form, remember, was ax squared plus bx plus c. The difference today is we're going to get that equation equal to 0. And instead of just factoring it, we're going to do a step after that. So it's quadratic because the biggest piece is x. The x squared is the largest exponent in there. And when you're solving by factoring, which is what we're going to do first, when you're solving by factoring, you want to, what we're using is what's called the zero product property. And it doesn't really, it's not super important that you remember the name of the property. You just got to know how it works. And what happens with the zero product property is the fact that if you multiply two things together or more things together and it equals 0, then at least one of those is 0. We're going to take worst case scenario that both of them are 0 and try to figure out what if either of these were 0, that sort of idea. So what we're going to be doing is we're going to be taking a quadratic and factoring it into its factored form, like maybe we did last week. We factored something and ended up with those two sets of parentheses. The difference today is that all is going to be equal to 0. And what the zero product property tells us is that either x plus 7 is equal to 0 or x plus 5 is equal to 0. It could be one of them. It could be both of them. We're going to take the worst case scenario is that it's both of them. And we're going to take each factor, each parenthesis, and we're going to set it equal to 0 and solve it. Okay? So we got x plus 7. We're going to set it equal to 0. And then we got x minus 5. And we're going to set it equal to 0. And we're going to solve each of those, okay, individually. So the first one, x plus 7, we're going to get x by itself. So I'm going to subtract 7. And that just gives x by itself. X equals -7. 0 minus 7 is -7. So that's one answer. The other answer, get by adding 5. X equals 5. And we've got it. Those are the two solutions to this equation. That if I put a -7 into this first piece, -7 plus 7 is 0. -7 minus 5 would be -12. 0 times -12 is 0. So that works to make that equation true. If I plug in a positive 5, 5 plus 7 is positive 12. 5 minus 7 is 0. Positive 12 times 0 is still 0. So that's how that checks in the problem there. So what we're doing is when we get it factored, we're going to take each parenthesis or each part that has an x in it and set it equal to 0. And then once we get it that done, we solve them just like the regular equations that we did back a couple of weeks ago. Okay. So they're not always going to be pre-factored for you. Sometimes you got to do it yourself. So let's start with one where we got to factor it, like x squared plus 5x, or excuse me, plus 7x plus 12 is equal to 0. So first thing that you've got to check when you're solving these kind of problems is that the equation is in the right order and it's equal to 0. So remember when we were doing our rules of factoring, first thing was descending order. Descending order. And then we're going to add there equal to 0 because we're solving. Okay, descending order equal to 0. And then the second thing we looked for was a GCF of the whole problem. So we're looking for x squared, 7x, and 12. The only thing that goes into all of those is 1. That really doesn't help us any. So GCF doesn't help us. The next thing we're going to do is count terms on the side that's equal to 0. So this side over here is what we're trying to count terms on. Remember, if there were 4 terms, we're going to do grouping there are 3 terms, I'm going to do that X method. We'll get some practice with that today as well. And if there are 2 terms, since we're dealing with quadratics, we're going to see difference of squares today. Okay. So this one has 3 terms, 1, 2, 3. And we're going to do the X method to factor that. So I'm going to make my X. 1 times 12 goes in the top. 12. Add to be 7 in the bottom. So we need numbers that multiply to be 12 and add to be 7. 6 and 2 multiplies to be 12, but it adds to be 8. So that's not right. 4 and 3 multiplies to be 12. 4 plus 3 is 7. So we know that that's the right pair. And remember that we had that shortcut. If there's nothing in front of that x squared, we could go straight to the factor x plus 4, x plus 3. It's plus on both of them because they're both positive. Now this red line here looks just like the first problem we did. We're going to take each parenthesis that has the x's in it, and we're going to set it equal to 0. So x plus 4 equals 0, x plus 3 equals 0. So take each factor and set it equal to 0 and solve it. So subtract 4, x equals -4. That's one of our answers. Subtract 3, x equals -3. That's our other answer. We get 2 answers on quadratics most of the time. Especially if we have to do X method of factoring, we're going to get 2 answers on those. Let's say we had something like this. 6x squared plus 7x is equal to +3. Okay, so this problem is the next kind of step up in the fact that it's not equal to 0 yet. So remember, we want descending order, and it's kind of in descending order, but it's not equal to 0. So we've got to get it equal to 0, and we got 6x squared and 7x over here. So this side already has most of the stuff on it, but this 3 is in the wrong spot. So we need to move it to the other side. To move that 3 to the other side, we're going to subtract 3. And it doesn't have any like terms over here. If it did, we would subtract it from its like term. 3 is a regular number. These both have x's, so they're not like terms. So we would then have 6x squared plus 7x, and then -3 is equal to 0. And so we're going to take that, and we're going to do the rules of factoring with it. We're going to look at it's in descending order. We got x squared, 7x, and then 3, and it's equal to 0. So we've taken care of that first one. Next thing to look for is the greatest common factor. 6, 7, and 3, they don't have something in common, so there's no GCF. And then we look at it and say, okay, how many terms are there? Well, 6x squared is 1, 7x is 2, and the -3 is the third term. So it's got 3 terms. So that's that X method idea. And what goes on the top of the X here is 6 times -3 is -18. So you take that number that's in front, the A, times the C. 6 times -3 gives me -18. And then 7 goes in the bottom. So it's something that multiplies to be -18 and adds to be 7. Well, 6 and -3 is how we got there. That adds to be +3. So that can't be right. What about 9 and -2? 9 times -2 is -18. 9 plus -2, 7. So that's the right pair. We can't take the shortcut on this one because we got something in front of the x squared. So this is where we're going to make that into a grouping problem. So we're taking 6x squared. I'm going to put plus 9x minus 2x minus 3. Okay. I'm replacing that 7x in the middle with the pieces from the sides of my x. That's how we did that. The next thing to do is to group that together. So first 2 together, last 2 together, and then get the GCF of each of those. So 6x squared and 9x has a GCF of 3x. 3x times 2x gets me 6x squared. 3x times 3 gets me 9x. The second set here has a negative 2x and a negative 3. What's the only thing that those two have in common? 1. And because there's a minus sign right here in the middle, and we're going to make that a negative 1 that we pull out. Remember that sign that's in front of this term, that third term there is always going to be the sign that's in the middle there. Okay? And then that'll mean, okay, well, that turns into positive 2x. Negative 1 times positive 3 gets me negative 3. So that's how that changes signs so that it matches up. The parentheses are matching. They don't match, something's went wrong. Okay. Next to last step is get the factors. One of them is the matching piece. The other one is the stuff in front. 2x plus 3 is this matching parenthesis. 3x minus 1 is the stuff in front. I've got it factored. That's the hard part. Okay, definitely that's the hard part of this lesson. The next part is to take each of those and set them equal to 0. And you got to just solve each of them individually, like two separate problems, get x by itself. So I'm going to subtract 3. Gives me 2x equals negative 3. One more step. Okay, a little bit more space here. One more step is be divide by 2. And we're going to leave it that fraction, negative 3 over 2. Do the other one. We need to add 1 first. Divide by 3. We get another fraction, 1/3. I want to show you something with your graphing calculator that can kind of help you in seeing what's really happening, what we're finding here. Okay, so what I'm going to do with the graphing calculator is I'm going to hit y equals. I'm going to clear out anything that I've got in there. I don't want anything else in there. And I'm going to type in the equation that was equal to 0. So the equation when it was equal to 0 was this one right here. That's what I'm going to type into the y equals thing. So I'm going to hit y equals, and then I'm going to type in 6x squared plus 7x minus 3. Okay. Make sure I got that right. 6x squared plus 7x minus 3. That's the right equation. All right. So once I've done that, I'm going to hit graph. And I can see that this thing is crossing the x-axis at 2 places. Okay. One of those places is between -1 and -2. Well, if I look at my answers that I got when I factored that, where is -3 over 2? We know that that's -1.5. That's between -1 and -2. So that tells me, hey, I think I'm probably right on that one. And then this one is 1/3. 1/3 is between 0 and +1, right? So we look at that graph, and right here, it's crossing closer to 0 than it is to 1, but it's between 0 and 1. And that's 1/3. Here's another way to check. Hit the trace button, which is up right on the top row. It's one that's highlighted in red there. It's right beside it says graph. And then type in the x value that you got. I got -3 divided by 2. Hit enter. Look at where that cursor is. It's right on it where it's crossing the x-axis. 1.5, it'll go ahead and convert your X value into a decimal, but it won't round it if it continues like, and I always leave them as fractions when I'm writing the answers on paper, because if it's like 2/3, it's going to be 0.6 repeating. And, you know, if you ever round that, it's not going to work out to be perfect there. So don't change your fraction answers to decimals when you type them in. Your calculator will automatically do that. And then I'm gonna type in trace 1 divided by 3 for the 1/3, and I bet the cursor ends up right there on that spot. And it does, right there where it's crossing the x-axis. So that's two ways you can look at this and check to make sure you're finding the right answers. If the graph crosses the x-axis, then the number that it's going to be that, you know, on the x-axis, that should be the answer you're getting when you solve it. That goes, you know, if it doesn't cross the x-axis, then there's something else happening, and we'll talk about that in a little bit. But if it crosses the x-axis, you should be able to look at the graph and tell for sure if you got it right or not. Okay, so that's going to be helpful for you, and we'll kind of try to do that some as we go along here. Maybe not on every problem, but some as we go. All right. Let's do another one. Let's say we had 3x squared minus 10x plus 6 equals 13. Hold on just a second. Let me make sure my numbers can work. I'm working out making up a new one here. So let's make that negative 21. Oh, excuse me, -1, not negative 21. -1. That works. That'll work for us. Okay. 3x squared minus 10x plus 6 is equal to -1. Okay. So we're going to solve this one by factoring. Okay. So again, the first step is always to look at it and get it equal to 0 and in descending order. So obviously this one is not equal to 0. It's equal to -1. So we need to move the -1 over there with its like term, which in this case is the 6. Okay, so we're going to get 3x squared minus 10x plus 7 equals 0. Okay. And then we look at that and say, okay, it's got 3 terms. Is there a greatest common factor? 3, -10, and 7? No, nothing goes into all of those. So I'm going to do X method. That X method, the top number will be 3 times 7, 21, and -10 is the middle number. So we need numbers that multiply to be positive 21 and add to be -10. Multiply to be positive 21, add to be -10. Good job. Okay, so -7 times -3 is positive 21, and it does add to be -10. So when I put that in the middle here to do my grouping, I'm going to put the -3 first and then the -7 second, because it makes it really easy to do the GCFs when you do it that way. Okay. Technically, it works either way, but I'm just trying to make it easy on myself. Okay. So then I'm going to group first 2 together, second 2 together. GCF of the first group, both of them are 3x. So that's going to leave x minus 1. Second group, 7 and 7. So we know it's a 7, but what kind of 7 is it? Negative, because this minus, it's in the middle there. So, and that'll leave us x minus 1 in there. And there we have the factors x minus 1. Whoops. I'm ahead of myself here. And then 3x minus 7 equals 0. That's the factored form of that problem. That's what that's called. Factored form. Sometimes it's called the intercept form. It's the same thing. Okay. So set each of those equal to 0. X equals 1. You just add 1. And then you want to show that step. 3x equals 7. This one's got a little bit more going on. So divide by 3. X equals 7 over 3. Again, if I were to graph this problem right here, if I graph that with my calculator, I should see it crossing the x-axis at 1 and 7 over 3, which we know 7 over 3 is 2 1/3. If you think about it as a mixed number there. So if I graph y equals, and clear out this one, 3x squared minus 10x plus 7. There it is crossing. If I hit trace at 1, there it is. And then I hit trace, 7 divided by 3. Hey, there it is. Perfect. We did a good job. That helps us. If it crosses the x-axis, we can do it that way. Okay, it's going to be helpful. If it'll factor, it'll cross the x-axis. It's never not going to. Okay. All right. So solving by factoring there. Let's do kind of the middle ground here of these types of problems. Is where we have something like this: x squared minus 16. Because this problem can be done in two different ways. One way is by factoring. Another way is by using square roots. And I'm going to show you both ways. I think square roots is probably quicker, but it's not any easier than doing differences of squares. Okay, so this one it's x squared minus 16 is equal to 0. It's already equal to 0, so I know I can use factoring to solve that. Or maybe I can. Okay, so because it only has two terms, I know, hey, my only option would be differences of squares. So I'm going to try to rewrite that as a difference of squares. So I know the first one's x. What squared gets me 16? 4. So that means that this factors x in the front of both of them, 4 in the back of both of them. One's a plus, one's a minus. I get my factors. And then I just set those equal to 0. And solve them. X equals positive 4. Or, excuse me, negative 4 and positive 4. My brain had already moved on. Okay. Plus and minus 4 out of that. If we were to graph x squared minus 16, y equals, clear, x squared minus 16. We see it crossing. We don't even have to type those in. We can see that perfectly, that it's crossing at negative 4 and positive 4. Works out wonderfully. Okay. So anytime it crosses, we can check that with that. Now, here's the other way to solve this problem using square roots. Okay, so this kind of introduces this method for solving. So factoring is an option that works a good bit of the time in Math 100, but it's not the only option. Square roots is also a good option. So let's say we had this same problem that we started with on example E, and I'm going to solve it by square roots. To solve it by square roots, there have to be certain conditions that are met. The condition is that you only have an x squared and a plain number. You don't have an x in the problem, like a plain x, like these problems up here had, where they had this term that had a plain x on it. If you're using square roots, you can't have that in there. So that tells you, when you can and can't use the square roots. Okay, this problem doesn't have that plain x in it, so that means we can do square roots. The difference in solving by square roots and factoring is that it doesn't need to be equal to 0. you try to get the x squared by itself by just adding 16. We get x squared is equal to 16. The next thing that you would do is take the square root of each side. Once you get the x squared by itself, you take the square root of each side. On the side with the number, you need to put a plus and minus in front of it, because when you square something, what's the square root of 16? What do we know about that? What square gives me 16? It's 4. But if I squared positive 4, I get 16. But also, if I square negative 4, I also get 16. So that's why we need to put the plus and minus in front of it. And this is the exact same answer that we got over here by factoring. Okay? So differences of squares can be solved by factoring or by square roots. Okay? So it doesn't matter to me which way you do those. You pick which way you think's the easiest on that. The kicker is when you have a number, a problem that looks like a difference of squares, but it's really not a difference of squares. It's just a, like this example, x squared minus 18 is equal to 0. That one looks very similar to examples E and F. It looks like it might be a difference of squares. The reason it's not is because 18 is not a square number. Okay, so that's how you can't rewrite 18 as 3 squared or 4 squared or 6 squared or anything like that. It's not a square number. So to solve this one, the best way to solve that is by square roots. So to solve by square roots, you need to get the x squared by itself. So the first step would be to add 18. Zero plus 18 is 18. And then, once you've got the x squared by itself, remember we're getting the squared part by itself, we're going to take the square root of each side. On the side with the number, we'll put a plus and minus in front of it. This relates back to what we did last week with the square roots when we simplified them with the factor trees, the little branches and things. That's what we're going to do here. Because 18 doesn't have a nice square root like 16 does, we can break 18 down. 9 times 2, and 9 is 3 and 3. There's a pair of 3s. So we know that that's going to turn into x equals plus or minus 3 square root of 2. This 2 here didn't have a buddy, so it goes back inside. The pair of 3s, that's the 3 on the outside. This 2 that doesn't have another 2 to pair with goes back on the inside. And we found that solution to where it's even on these, you can check with graphing. So if I went to my calculator and I graphed when it was equal to 0, x squared minus 18. I see it crossing the x-axis. If I hit trace 3 square root of 2, hey, right there it is. Bet you this other one is the negative side of that. So I could hit trace negative 3. To get the square root again, you go second, and then right above the log button is the x squared button. That gets you the square root of 2. And there it is. It's crossing the x-axis there. So this one happens to cross the x-axis at a nice place. All right. Let's look at one that's a little bit more difficult, but it's still a square roots problem. Maybe it has 8x squared minus, let's do 10, is equal to 46. So the first thing that I should notice about that problem is that it doesn't have a plain x in it. It's got an x squared, and then it's got 2 numbers that are just regular numbers out of that. So when I see a problem that doesn't have a plain x in it, I automatically think solve by square roots because it's the quickest way to get an answer. Okay. Now, first thing that I would do would be get the x squared by itself. Remember, that's what your job is, to get the x squared by itself. If you're going to solve by square roots, that's what you've got to do. So, first thing I would do would be move the 10. That's 46 plus 10 is 56. And then x squared is not quite by itself yet. It's got that 8 in front of it. So I'm going to get rid of that 8 by dividing. That's going to give me x squared is equal to 56 divided by 8 goes evenly, goes 7 times. Now the x squared is by itself. Because the x squared is by itself, I can take the square roots of both sides. So square root plus or minus square root. That gives us plain x on the left. 7's a prime number. If I try to break it down with the factor tree stuff, it doesn't do anything. So nothing I can do. I'm just going to leave it plus or minus the square root of 7. Checking that with the calculator is a little bit more difficult. You need to make sure you can get that equal to 0. And you could check it that way. This would end up being 8x squared minus 56 is equal to 0. And yet that's what you would graph, is 8x squared minus 56. Oops, I got all that other stuff in there. X squared, 8x squared. Try again here. There we go. 8x squared minus 56 graph. And we see it crossing the x-axis. If I hit trace square root of 7, I bet I got the right place. And I know the other one's the same thing. Not very likely that you'll get one of them on the square root problems and not get the other one right too. Okay, so you can check one of those and be plenty. All right, let's do another one here. X squared plus 4 is equal to 0. So this one's already equal to 0, but it's got a plus sign in the middle of it instead of a minus sign in the middle of it. So that plus sign right there tells me I can't do this one by factoring no matter what. So my only option is to do it by square roots. I'm going to show you what the graph of this looks like because it's a little different. So y equals, I'm going to clear that out and write x squared plus 4. Notice that this graph does not cross the x-axis. So that means that we can't check it that way. So we've got to be extra careful in solving this one. So what we're going to do is do the same things. We're going to solve by square roots. We're going to subtract 4 to get rid of it and get it over here with the 0 and get x squared is equal to -4. The same way that we've done all these last 4 problems that we've done with square roots. Okay, get x squared by itself. Okay, next thing to do is take the square roots of each side. Still put the plus and minus in front of the one with the number. X squared, the square root of x squared is x. What's the square root of 4? 2. What does the negative underneath the square root do? Remember the I? That's where that I comes in. These are complex solutions. Okay, so 2I is how you would write that answer. Plus or minus 2I. Because it's a negative under there, that's where the I comes from. The number part, still the same rules. You take the square root of it. It's a nice square number, you take the square root. If it's not, you do the factor tree to try to break it down and get that number out of there. Okay. Let's look at another one. J. Say we had negative 3x squared minus 6 equals 18. I look at that problem and I'm thinking, okay, well, it doesn't have a plain x in there, so that tells me I can't do factoring with this. So I'm probably going to end up having to get x squared by itself and do square roots, which is the right way to do this one. So the next thing I would do would be get x squared by itself. So I see this minus 6 here. I'm going to get rid of it by addition. That's going to give me negative 3x squared is equal to 24. And then the next step, I got this negative 3 that's here that's in the way, so I need to get rid of that by division. It gets me x squared is equal to negative 8. And now I've got x squared by itself, so that means I can take the square root of each side, plus and minus on the number side. There's x. And then square root of 8 is not a pretty number, so I'm going to do the factor tree for that. Give myself a little more room. 4 and 2, 2 and 2. There's a pair of 2's and then a 2 left over. So that's going to be plus or minus 2. And then because it was a negative 8, that's going to be an I on the outside. And then square root of 2. The I is coming from the negative. Anytime you're taking a square root and there's a negative inside, you're going to have that I on the outside, just automatically. And then the number part, you're just going to break it down. 4 and 2, and the 4 breaks down into 2 and 2, so that's a pair of 2's. That's this 2 on the outside. This 2 that's left over goes on the inside. Okay. All right. Let's look at this problem. Let's say we had parentheses x minus 3 squared minus 5 equals 15. All right, so this one looks a little different. It is doesn't have just a plain x squared in it. It's got a parentheses squared. So here's the trick to this is it looks really complicated, but we can make it easier by solving it by square roots like we did the other ones. And just try our best. We're going to, the way that we're going to do that is we're going to get that part that I've just highlighted, we're going to get that equal to the other stuff. We're going to get that by itself, just like we got x squared by itself with the other problems, okay? So we're going to get this squared part. That's what I call that, the squared part by itself. So to do that, I just need to move this 5 out of the way. That 5 is not part of the squared part. It's outside of it. So I'm going to move it by addition. That gets rid of that and leaves me x minus 3 squared is equal to 15 plus 5 is 20. Okay, so I've moved the stuff and got the squared part by itself. So that's what we're saying there. This is just like if we had gotten the x squared by itself, because now the squared part is equal to a number. And I can take that and take the square root of both sides. Plus or minus on the number side. What happens on the left side is that the squared goes away and we're left with just the stuff that's underneath, that x minus 3. On the right side, we've got to simplify that if we can. If it were a good number like 16 or 25 or something like that, I would get that number. But it's a 20, so it doesn't have a nice square root. So we're going to break it down. Give myself a little more room here. 4 and 5, 2 and 2. There's a pair of 2s and a 5 left over. Okay. So that's going to be x minus 3 is equal to plus or minus 2 square root of 5. Notice that there's not an I out here because that was a positive 20. Had that been a negative 20, there'd have been an I on the outside. Okay, it was positive, so that we don't have I's when there's positives. The last step is get x by itself. Plus 3. And here's the thing. This 2 radical 5 or 2 square root of 5 and the positive 3, yeah, they're both numbers, but this one is a irrational number and this one is a regular number, so we can't put those together. So we're just going to leave this x equals 3 plus or minus 2 square root of 5. Had that been a nice number, like plus or minus 6 or something like that, then we would have worked it out. But it's a radical and a number without a radical, so we can't put them together. We're just going to leave it like that. All right. So solving by square roots when it's got a squared part, not necessarily a just a square variable. Let's look at one more of those before we move on to the last method. Let's say we had something like this. 3 parentheses x plus 6 squared plus 5 is equal to 17. Okay. So this one has a lot more going on. Not a ton more, but it's got a 3 out here in front of the squared part, and then the plus 5, and then the 17 over here. So we want to get the squared part by itself. Again, we're trying to get this part alone so that we can take the square root. Anytime we see a problem with those parentheses like that and the squared on it, to solve it, that's the best route to take. There are other routes, but they take a lot longer, a lot more work, a lot more operations, a lot more room for mistakes. Okay, so we're going to try to do that. These don't come up a bunch. I just want to show you a few of them so that you're, when you see one, you're not just, panicked out of that. So these don't happen a lot, but they do come up. So I want to make sure that I've covered a few. So we're getting rid of the 5 because it's not attached to that at all. So it's on the outside, so we can get rid of it. So that's going to give me 12. And I got 3 parentheses x plus 6 squared. Well, that 3 hanging out there in the front, I need to get rid of it. So it's 3 times that. So I'm just going to divide by 3 to get rid of it. And 12 divided by 3, that goes nice and evenly. That's 4. Hey, that worked out nice. And then the squared part is by itself. That's what I wanted. Because now I can take the square root of each side. Square root plus or minus square root. Hey, the square root of 4 is a good number. It's plus or minus 2. And on the other side, I've got x plus 6. So those are regular numbers. 2 plus or minus 2 and 6 are regular numbers. So that means when I solve this by subtracting 6, I've got negative 6 plus or minus 2. I can work that out because those are like terms. Negative 6 plus 2, I can work out. That'd be negative 4. Negative 6 minus 2, that'd be negative 8. So I'm working those out because those are regular numbers. If this had a square root on it, I wouldn't even work it out. I'd just leave it this way. Okay? So if you see those and that square root turns out to be a nice number, go ahead and work them out, because it works out to be a like terms. So you can work those out a little bit more. Okay? So solving by square roots can be handy when we're dealing with those kind of problems. All right. Now, solving by factoring, it's got to be equal to 0. You got to do the X method or differences of squares. Those are special times, because not every polynomial factors. Not everything's a difference of squares. Well, to solve by square roots, you can't have a plain X in the problem. You got to have squares, right? Not every one of them has squares. What happens when you have a problem that doesn't factor? Like I tried the X method and it didn't work. And it can't be done by square roots or differences of squares. So that's where this last method comes in. And it's actually the most powerful method because it always works. No matter what, this method works. That method is called the quadratic formula. Quadratic formula. And it comes from the standard form of a quadratic. And it's just like if we were doing it by factoring, the problem has to be equal to 0 to do quadratic formula. Okay? To do quadratic formula, you got to make sure that you're equal to 0. If it's not equal to 0, work it till it is. Work with it till it is. Then you can do quadratic formula. Notice it's in standard form. It's in descending order. It's got to be that way. Okay? The way quadratic formula works is you got x equals negative b plus or minus the square root b squared minus 4ac, all of that on the top of the fraction, and then it's divided by 2a. Okay. Negative b plus or minus radical or square root b squared minus 4 times a times c divided by 2a. Okay. I teach this to my high school students. I make them memorize it. I don't let them get to use notes and stuff. And I always sing a song with it. I won't put you through the torture listening to me sing, but it helps them memorize it because it just puts it to the tune of "Row, row, row your boat," and they memorize it pretty quickly that way. But the A, the B, and the C are all the numbers from this particular equation, whatever the equation goes. All right. And we're going to solve some quadratics using quadratic formula. The good news is quadratic formula works no matter what. Okay. It's going to get us answers no matter what. And we just got to be able to put in the stuff in the right place. Okay. So let's look at some examples for this. X squared minus 4x is equal to negative 2. All right. So this problem, we know it's quadratic because it's got x squared in it, but we know it's not equal to 0. So I need to go ahead and get it equal to 0. I know I can't do it by square roots because it's got a plain x in it. So I know I've got to get it equal to 0 so that I can either do factoring or quadratic formula. We're going to do quadratic formula here. So I'm going to do my first step to be add 2. X squared minus 4x plus 2 equals 0. Okay. And I think it's always helpful to make yourself a list of what A, B, and C are, so that you get that and you're conscious of what those numbers are. Well, A is always in front of x squared. What number is in front of x squared here? 1. There's nothing written there. It's a 1. B is in front of the x. That's a minus 4, so we're going to write negative 4. And then this is a 2 right here, so C is 2. So we know A is 1, B is -4, and C is 2. So in the quadratic formula, everywhere we see a B, we're going to put in a -4. Everywhere we see an A, we'll put in 1. Everywhere we see C, we're going to put in 2. All right? So it's just plugging things into the formula and then working it out. So negative B, that means change the sign. So -4 would be +4. B squared, so that's -4 squared minus 4 times A was 1 times C is 2 over 2 times A. Okay. This 4 and this 2 are always in the problem. Okay. Those never change. Everything else comes from your equation. Okay. That 4 and that 2 are always in this problem, in the formula. Okay. Now we're going to work that out. -4 times -4 is +16. 4 times 1 times 2, that'd be -8. 2 times 1 is 2. And then I'm going to simplify a little further. 16 minus 8 there inside of the square root is the square root of 8. And then I can simplify the square root of 8. Remember with the factor tree stuff. 4 and 2, 2 and 2. There's a pair of 2's. So that's going to be 4 plus or minus 2 square root of 2, all divided by 2. Okay. The last thing that I'm going to do is split it apart. It's 4 over 2 plus 2 square root of 2 over 2, and then simplify. That's plus or minus, sorry, between there. And then simplify each fraction. Okay. 4 divided by 2, that's 2. This 2 and this 2 can cancel each other out. And that's going to be my answers for x. 2 plus or minus the square root of 2. All right. Now, let's do another one. There's nothing like practice for this. All right. Let's take in x squared minus 3x plus 5 is equal to 15. Okay. X squared plus 3x or minus 3x plus 5 is equal to 15. Okay. So we're taking that and we're going to get it equal to what? Got to get it equal to 0 to either do factoring or quadratic formula. We're going to do quadratic formula because that's what we're practicing here. Okay, so I'm going to move the 15 by subtraction. X squared minus 3x minus 10. 5 minus 15 is where the minus 10 comes from. And now it's equal to 0. So that means I can either factor it or do quadratic formula. We're doing quadratic formula here to get the practice with it, but we're trying to just get the process down. Okay, so I need to know what A, B, and C are. So A for this one would be 1, B would be -3, and C would be -10. Be careful to take that sign with you when you make your list there. X equals -b plus or minus the square root b squared. Not a little clearer here. Square root b squared minus 4ac divided by 2a. So I'm just writing that formula again kind of helped me memorize it a little bit so I don't have to look back so much for that. So next thing, plug in your stuff. Negative b, so that's a -3. So negative makes it +3 plus or minus -3 squared. 4 times a times c is -10 this time, over 2 times a. A was 1 again. And then we're going to simplify that as we go here. So we got 3 plus or minus. -3 squared is 9. -4 times 1 times -10 would be +40. So that minus sign on the 4, treat it as a -4. -4 times 1 times -10, +40. And then on the bottom, we got a 2. And we know that that's 3 plus or minus the square root of 9 plus 40, be 49 over 2. If you're doing this with the calculator, if I'm typing this in the calculator, this regular calculator screen, make sure you use parentheses around, the b squared minus 4ac stuff. Okay, so I'm working out the inside of the square root, minus 4 parentheses 1 parentheses -10. Make sure you're using parentheses. If you don't, a lot of times you'll get a sign mistake happening. And when I do that, enter, I got 49, which is what I got by working it by hand there. So the calculator, as far as that goes, I wouldn't type in the whole quadratic formula into the calculator. I would do separate pieces, like part underneath the square root. That's what I'm doing right there. And then, okay. Well, what's the square root of 49? 7. So 3 plus or minus 7 over 2. Hey, 3 and 7 are regular numbers, right? So I can work that out. 3 plus 7 and divide that by 2. That'd be 10 divided by 2. Hey, 10 is divisible by 2. It goes 5 times. Then I could do 3 minus 7 over 2. 3 minus 7. 3 minus 7. -4 over 2 ends up being -2. I got two answers. I got x equals 5 and x equals -2 out of that. Okay, that tells me, hey, that it should be crossing the x-axis at those two places, and those are easy to check. Remember, to check something, we're going to graph it. So we're going to take this problem right here where we had it equal to 0, and we're going to graph this part over here on the left. So y equals, clear that one out, x squared minus 3x minus 10. We see right there, there's the -2 right there on the left of the origin. 1, 2, 3, 4, 5. There's the +5. I don't even have to trace to do that. I can see exactly where they're crossing there. So there's a good checking method for that using the quadratic formula. Works out real nice. Let's do another one with quadratic formula here. All right, 2x squared minus x plus 3 is equal to -1. All right, what's our first step here? Make it equal 0. So add the 1 to the 3. So that's going to get it equal to 0. So that's always going to be our first step when we see that it has an x squared and a plain x. We know we've got to get it equal to 0. And then once we've done that, options are either factoring or quadratic formula. Quadratic formula always works. Factoring doesn't. So I tend to lean toward doing it that way if I got a choice. This one we need to do quadratic formula anyway, just to practice it for sure. And I happen to know that this one won't factor either. So 2, -1, and 4. I'm going to write out the quadratic formula one more time just to help me memorize it. And then plug in the stuff that I know. I got -b, so that's 1 plus or minus. And if b were a positive number, you would make it negative out here. So always swap the sign on the front there. It's always swap the sign for the -b. Whatever b is, change the sign of it into the formula there. And then we got -1 squared. 4 times a is 2. C is 4. On the bottom, C is, or 2a, 2 times 2 on the bottom. So it's 4. And then start simplifying. So we get 1 plus or minus. And then I know I got 4 on the bottom. So I'm going to go to the calculator. I'm going to get it some help here with the part that's underneath the square root. Parentheses, -1 squared minus 4 parentheses 2 parentheses 4. -31. All right. Not the best number in the world. It's negative, so what do we know comes out of the square root? Anytime there's a negative under the square root, what do we know comes out? I. 31 is a prime number, so I know it's not going to break down. That's going to be my solutions to that problem. Okay. Happens to be a complex solution. It could be written like this: 1 over 4 plus or minus square root of 31 over 4i. That's another way that it could be written. You might see it that way. That's just splitting it apart into 2 fractions. The reason you would do that would be to try to simplify the fraction if it could. Doesn't necessarily mean that it will. Okay. All right. Now, last thing that we want to talk about in this particular section, and we'll take a break, is that part that's underneath the square root. When you've got the quadratic formula, this part that's underneath the square root, it has a name. It's called the discriminant. The discriminant discriminates what kind of answers you've got. Okay? And knowing what kind of answers you're supposed to get can be helpful in knowing whether you got it right or not, and also knowing what the graph is going to do. So the discriminant is the b squared minus 4ac part. So it's just the part that's under the square root of the quadratic formula. No, nothing fancy about that. Here's what we know about the discriminant. The way it tells us what kind of answers we'll find is that if b squared minus 4ac, if we work that out, and we get an answer that is less than 0, what kind of number is it? What kind of numbers are less than 0? Negative numbers, right? Because if my bank account goes below 0, I got a negative balance, right? So that's numbers that are less than 0. If it is negative, okay, so in parentheses, just write that negative. That means we're going to have 2 complex solutions. Okay. And on the quiz and on the final exam, that may be the only thing they ask you is what kind of answers you have. Not that you necessarily have to find them, just what kind are you going to have. And the way to find that is with the discriminant. Just work out what's b squared minus 4ac. If it's negative, there's two complex solutions. Complex, remember, that's got the I in it. If b squared minus 4ac is equal to 0, that means we're going to have one real solution. One real solution. And then the last case is, what if it's greater than 0? Or it's a positive number? There we'll have two real solutions. Okay. There are some special cases where there's only one real solution, and that special case is when the discriminant b squared minus 4ac is equal to 0. That's the only time that there's only one solution to a quadratic equation. The rest of the time, there should be two. Sometimes it's two real ones. They don't have the I. Or sometimes it's two complex ones where they do have the I involved out of that. All right. So first section is about all the ways to solve a quadratic equation. Very important section. A lot of stuff in there. Quadratic formula always works. That's what I want to kind of drill to you. Quadratic formula always works. The other methods, they got to be special for them to work. So if you got to pick one to learn and really be good at, you better pick quadratic formula because it always works. No matter what, you'll get answers with quadratic formula. Factoring doesn't always work. Difference of squares doesn't always work. Square roots doesn't always work, but quadratic formula always works. You should really focus a lot on doing quadratic formula a lot when you're practicing for this and getting ready to solve some quadratics out of that. All right, let's take a short break. Let's take about 10 minutes and breathe for a second, and then we'll come back and do some more quadratic stuff. I think the rest of the sections that we're going to cover today are not quite as long as that one is. So let's take a short break.